Moving on to 8th question. Show that angles of equilateral triangle are 60 each. Now moving on to the solution. He asked us to prove that angles in an equilateral triangle are 60 degrees each. Now initially, before finding that angles in an equilateral triangle are 60 degrees, let us know what is equilateral triangle. We can say a triangle is said to be equilateral if all the sides of triangle are equal. Now let us draw an equilateral triangle ABC in which all the sides are equal, that is AB is equal to BC is equal to CA. We know that in triangle the angles opposite to equal sides are equal. We can also say that angle A is equal to angle B is equal to angle C. Let us assume that all the three angles is equal to x degrees. We know that sum of angles in any triangle is equal to 180 degrees. We can say angle A plus angle B plus angle C here will be equal to 180 degrees, which implies angle A is x degrees plus angle B is x degrees and C is x degrees is equal to 180 degrees, which implies 3 times x degrees is equal to 180 degrees. That implies x degrees is equal to 180 degrees by 3, which is equal to 60 degrees. Therefore, we got angle A is equal to angle B is equal to angle C is equal to 60 degrees. All the three angles in the equilateral triangle are 60 degrees, which is the required proof. Moving on to first question. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on same side of BC. If AD is extended to intersect BC at P, show that triangle ABD is congruent to triangle ACD, and second, triangle ABP is congruent to triangle ACP, and AP bisects angle A as well as angle D, and fourth thing, AP is perpendicular bisector of BC. Now moving on to solution. In the first question, he asked us to prove triangle ABD is congruent to triangle ACD. So let us consider triangles, triangle ABD and triangle ACD, and let us check the similarities in them. Now if we consider triangle ABD and triangle ACD, we can say that AB is equal to AC as given that they are isosceles triangles. ABC is isosceles triangle. And we can also say that DB will be equal to DC as he has also given that DBC is also a isosceles triangle. And here we have AD as a common side for both ABD and ACD. Now, according to side property, triangle ABD is congruent to triangle ACD. Now, in order to prove the second proof, let us consider the triangles ABP and triangle ACP. ABP and ACP. In these triangles, AD is equal to AC as he has given that ABC is isosceles triangle, and also angle B will be equal to angle C as in isosceles triangle angles opposite to equal sides are equal. So we can say that from above step or above given equality, we can say angle B is equal to angle C. And also in this, AP is a common side for both the triangles. Now by SAS property, we can say that triangle ABP is congruent to triangle ACP, which is the second proof we require. As triangle ABP is congruent to triangle ACP, we can say that corresponding angles and corresponding sides in both the triangles will be equal. Thereby, we can equate angle BAP and angle CAP. That is, angle BAP is equal to angle CAP. Now, as angle BAP is equal to angle CAP, we can say that AP is bisecting angle A. And also, we can say that BP is equal to PC, as corresponding sides of two congruent triangles, triangle APB and APC, are equal. And thereby, we can say that in triangle BDC, if we consider that P is midpoint of BC, as BP is equal to PC, angles opposite to equal sides are equal. Therefore, we can equate angle BDP is equal to angle CPD. Therefore, we can say that DP is bisecting angle D. Or if we take extension to A, we can say that AP is bisecting angle D. Here we proved that AP is bisecting angle A and angle D both, which is the third proof required. In order to prove that AP or DP is bisecting angle BDC, let us initially prove the congruency of triangle BPD and CPD. Now, so let us consider in triangle BPD and triangle CPD, DB is equal to DC, as given that DBC is isosceles triangle, and we can say that DP is equal to DP, which is a common side. Now, angle DBP and angle DCP will be equal, as they are the opposite angles for the equal sides BD and DC. So we can write angle DBP is equal to angle DCP, as angles opposite to equal sides are equal. Therefore, by SAS property, we can say that triangle BPD is congruent to triangle CPD. When two triangles are congruent, then their corresponding sides and corresponding angles will be equal. Therefore, we can equate both the angles BDP and CDP. BDP is equal to angle CDP. Therefore, as both the angles are equal about the line DP, we can say that DP or its extension AP is bisecting angle D. Therefore, we can say that AP is bisecting both angles, angle A and angle D, which is the third proof we require. From above congruency, we can say that BP is equal to CP. As BP is equal to CP, we can say that AP is just bisector, and we can also equate the corresponding angles, that is angle CPD is equal to angle BPD. And here if we observe clearly, P is a point lying on BC. So angle BPD and angle CPD form a linear pair. We know that sum of angles that form a linear pair is equal to 180 degrees. We can write angle CPD plus angle BPD is equal to 180 degrees, which implies angle CPD can be replaced by angle BPD plus angle BPD is equal to 180 degrees, which implies angle BPD plus angle BPD is 2 times angle BPD, which is equal to 180 degrees. That implies angle BPD is equal to, by transposing 2 on right hand side, we get 180 degrees by 2, which is equal to 90 degrees. So we can write that angle CPD is equal to angle BPD is equal to 90 degrees. So AP is a bisector and it is perpendicular to the base. So we can say that AP is perpendicular bisector of BC. Moving on to third question. Two sides AB and BC and a median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. Show that in the first question, triangle ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. Now moving on to solution, he has given that side AB in triangle ABC is equal to side PQ in triangle PQR, and also BM is equal to QN, and also AM is equal to PN. This is a given data. Now in the first question, he asked us to prove the congruency of triangle ABM and triangle PQN. So now let us consider the triangle ABM and triangle PQN. In this, AB is equal to PQ is given, and BM is equal to QN, which is also given, and AM is equal to PN. This is also given. Now according to the side property, triangle ABM is congruent to triangle PQN. Now in order to prove the congruency of triangle ABC and triangle PQR, let us consider them and check the similarities for them. Here in triangle ABC and triangle PQR, AB is equal to PQ, which is given, and now let us consider the statement that BM is equal to QN. Now multiplying this equation by 2 on both sides, we get 2BM is equal to 2QN. We can say that as AM is median, M divides BC in ratio 1:1, and we can write 2 times the BM as BC, which is equal to, similarly in triangle PQR, as PN is median, that we can say that N divides QR in the ratio 1:1. We can say that QN or 2 times QN is equal to QR. And next we can say that angle B is equal to angle Q, as we proved the congruency of triangle ABM and triangle PQN, and thereby applying the concept that corresponding angles of two congruent triangles are equal, we can say that angle B is equal to angle Q. Thereby we can say by applying the side property, the triangle ABC is congruent to triangle PQR, that is by SAS property. Moving on to fourth question. BE and CF are two equal altitudes of triangle ABC. Using RHS congruence rule, prove that triangle ABC is isosceles. Now, moving on to the solution. Let us consider a triangle ABC in which BE and CF are equal altitudes. Then, in the question, he asked us to prove that ABC is isosceles. In order to prove that ABC is isosceles, we need to prove that two sides of triangle are equal. So, in order to prove that, let us prove that angle B is equal to angle C by initially proving the congruency of two triangles BEC and BFC, and then by applying the concept that corresponding sides and corresponding angles of two congruent triangles are equal, we can get the angle B equal to angle C, and thereby we can prove the sides opposite to equal angles are equal. So let us consider the triangles, triangle BEC and triangle BFC. In this, let us note down the similarities. Angle BFC is equal to angle BEC is equal to 90 degrees, as CF and BE are altitudes to sides AB and AC respectively, and he has given that BE and CF are equal altitudes, so we can equate BE is equal to CF, which is given, and here we have the common hypotenuse to both the right angle triangles BFC and BEC. Therefore, by RHS property, we can say that triangle BFC is congruent to triangle BEC. When two triangles are congruent, then their corresponding angles and corresponding sides will be equal. So now we can equate angle B in triangle BFC to angle C in triangle BEC. One more thing, we know that in a triangle, the sides opposite to equal angles are equal, so we can equate AB is equal to AC. If in a triangle, two sides are equal, then it is isosceles. So we can finally say that ABC is isosceles triangle. In the fifth problem, ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. Moving on to solution, let us consider ABC, an isosceles triangle with AB is equal to AC, and let us drop a perpendicular AP to BC. And here he asked us to prove that angle B is equal to angle C. Now, in order to prove that angle B is equal to angle C, if we are able to prove the congruency of triangles APB and APC, and then by applying the concept that corresponding angles and corresponding sides of two congruent triangles are equal, we can get that angle B is equal to angle C. Therefore, now let us consider triangles, triangle APB and triangle APC, and let us note down the similarities between them. That is, angle APB is equal to angle APC is equal to 90 degrees, as AP is perpendicular to BC. Then AP is equal to AP for both the triangles as it is a common side. And also AB is equal to AC as given that ABC is isosceles triangle. Here, by right angle hypotenuse side property, we can say that triangle APB is congruent to triangle APC. When two triangles are congruent, then their corresponding sides and corresponding angles will be equal. Therefore, we can equate angle B is equal to angle C, which is our required proof.